In the last lecture of Module 1, Section 3, we're going to finish our discussion on electrophysiology. So in Lecture 4, we're going to define the absolute refractory period, define the relative refractory period, and explain why cellular stimulation during the relative refractory period is vulnerable to the development of lethal arrhythmias. So a couple of terms to remember that we've already discussed. A synctium. This is when the cardiac muscle cell groups are connected together and they function as a unit. Remember, you've got to have an atrial synctium to where they squeeze at the same time, and a ventricular synctium. And the electrical aspect of the heart and the mechanical aspect of the heart have to work together in order for the synctium to continue. Then the polarized state. The polarized state, this is the resting state of the cell. Remember, the inside of the cell is electrically negative relative to the outside. So during the polarized state, remember that the inside of the cell is full of potassium and the outside of the cell is full of sodium. So the cardiac muscle refractory period, if you notice, this is during the phases of the action potential. You've got the absolute refractory period, and then you've got the relative refractory period. So refractory periods are the period during which the cell is depolarized or in the process of repolarizing. It consists of two phases, as I mentioned. The first half represents the absolute refractory period, a period of time from phase 0 to the middle of phase 3, so phase 0 to the middle of phase 3, in which the ventricles have not sufficiently repolarized to enable another depolarization. The second half represents the relative refractory period, so we're finishing up the repolarization. The cells are getting ready to rest, but they're not quite there yet, which indicates that some cells have repolarized sufficiently to depolarize again, but not all cells are ready to depolarize, and so if you actually have a stimulus, the cell will actually respond, but it will not give a full contraction, and this can actually cause what's called R on T phenomenon, which can actually cause a lethal arrhythmia. So the refractory period, another way to think about it, attempts to ensure muscle is totally relaxed before another action potential or depolarization can be initiated. So that's where the refractory periods come in, is trying to get this period of rest. Atrial muscle is about 0.15 seconds, and the ventricular muscle is about 0.25 to 0.3 seconds. The period of rest is referred to as cardiac repolarization. So the absolute refractory period. The cardiac cell is unable to respond to a new electrical stimulus, and it cannot spontaneously depolarize. So no matter what happens during this time, the cell is not going to depolarize. The cell is trying to get itself back to its resting potential. So think about it in terms of a toilet. I know it's a weird comparison there, but if you have a toilet, if you flush the toilet, once you flush the toilet, you get a full flush. If you try to flush the toilet again before the bowl is filled back up, the toilet is not going to flush very well. So during the full flush, at first, if you try to flush it, nothing's going to happen. That would be the absolute refractory period. But as the bowl fills back up, even though it's not completely full, if you try to flush, you will get a very poor flush. You won't have the action that you need for the toilet to complete the flush. This is a relative refractory period. Repolarization is almost complete. The cardiac cell can be stimulated to contract prematurely if the stimulus is stronger than normal. So in this case, the cell is not completely to its resting potential yet, but if it receives a stimulus, it's going to actually start its work over again before it gets fully rest, which can make it very irritated and actually cause lethal arrhythmias. So in review, you have your relative refractory period and your absolute refractory period. Your absolute refractory period occurs during phase 0 to the middle of phase 3. On the EKG itself, it would actually start at the Q wave to the peak of the T wave. Then the relative refractory period picks up at the middle of phase 3, and it goes until we get to our resting potential. And on the EKG, this would actually be at the peak of the T wave to the end of the T wave to where the cell gets into its resting potential. So this concludes Module 1, Section 3, Lecture 4.